In this lecture, we're going to take a look at the phase of matter of liquids. Now, we talked about solids. We said solids had definite shape and definite volume, which meant when they were left alone, they would just keep their shape and their volume. Solids will keep their volume, but they have an indefinite shape. So if you have a pitcher of water, and you take that pitcher, and let's say it's a cylindrical shape, and you pour that cylindrical shape of water, let's say you have 1 gallon, into a square bucket. You're still going to have a gallon of water, but now it's going to be square. The reason that liquids will take the shape of the container is because there's a weak cohesive bond between the molecules. Remember, in a solid there was a rigid bond between the atoms, each one was holding each other in place. When a liquid, this cohesive bond, or this bond between like atoms, is very weak. So the atoms can move around kind of where they want to independently, but they are still held together. Like 2 water droplets as they go down your windshield, when they get close to each other, they're going to cohere, or they're going to join together, because they want to be together. They're just not held in a rigid spot. Liquids have density, just like solids do. All states of matter have density, as a matter of fact, but liquid density, we can see an example of it here where we have 5 different liquids, each one with a different density. Honey, where the molecules are closest together, is at the bottom, and vegetable oil is the least dense and it sits on the top. And we know from experience that water and oil don't mix because they have different densities and they're going to separate over time. We use the same formula. The units kilogram per meter cubed or gram per centimeter cubed are the same. We're still talking about a 3-dimension here, but we're talking about in terms of fluids. Surface tension is a property of liquids. Surface tension is this bond that the liquids have on the surface or the top of the object. If you look at the water molecules, you can see one water molecule is going to bond to 4 other molecules. But on the surface, it doesn't have anything to bond to above it. So it's going to create a double bond between the molecules on either side of it at the surface level. And this creates a stronger surface tension there than underneath. This is called surface tension. What's created a raindrop? A raindrop is held together by surface tension. Little fun fact, if a raindrop didn't have gravity, it wouldn't have that teardrop shape. It would be a perfect circle. Another property of matter would be Pascal's Law. And Pascal's Law is how hydraulics work. When you apply a pressure at one part of a liquid, it's transmitted without loss to all parts of the liquid and to the walls of the container. So if you looked at that example on the bottom left, A goes down, B goes up. And you can see all the little balls moving from one side, and those balls represent the atoms. The number of atoms has to move equally on both sides. So A moves a much further distance down than B goes up. Now the force per unit area, that's the pressure. The force per unit area is going to be the same on A and B. But the work is also the same. And the work is also the same. So the work done at A is equal to the work done at B. But remember, work is force times distance. So A has to move a much greater distance because there's less force applied than B does. And this obeys the law of conservation of energy. This same idea works on your brakes. When you push on the brakes, you push with a small force. It compresses the liquid inside the brake line, and that brake line then will put a tremendous amount of force on your brake pad as the area changes of the cylinder. The pressure in the liquid is greatest at the bottom. The deeper you go in a liquid, the greater the pressure is. This is because pressure in a liquid is determined by depth and density. The deeper it is, the more pressure there is. The more dense it is, the more pressure it is. This is why when you swim in the bottom of a 10-foot pool, your ears pop, because there's a greater amount of pressure. It's that column of water directly above you that creates the pressure. You can see on the bottom of this rock, the arrows are larger, and this represents a greater amount of force, which would give you a greater pressure. If we had 3 holes poked in a cylinder, the hole on the bottom would shoot the furthest out because there's the greatest amount of pressure pushing on that water. The hole at the top would just dribble out. Pressure is the amount of fluid directly above you. So it doesn't matter how much is on the left of you, how much is on the right of you, how much is underneath of you. It's only above you that creates this pressure. So if two people were swimming in a 10-foot deep water, one was in a huge lake and the other was in a swimming pool, assuming they're both fresh water, they're going to have the same amount of pressure on them. It doesn't matter how big the body of water it is. Only thing that matters is how deep you go and the type of water. From this pressure, we get buoyancy. Because the forces at the bottom are greater, the net force acting on an object is upward when it's submerged in a fluid. So this creates an upward force acting on the object we call buoyancy. If the buoyancy is greater than your weight, or the buoyant force is greater than your weight, you are going to have a positive buoyancy and you're going to float. If your weight is greater than the force of buoyancy acting on you, you have a negative buoyancy and you sink. A neutral buoyancy would be when your weight is equal to the buoyant force. So a positive buoyancy would be like a boat. A boat is going to create a force upward on it greater than the weight of the boat, so it'd float. A negative buoyancy would be like a rock. And a neutral buoyancy would be like a fish or a submarine. They change the amount of air that's in them to change their weight, and this allows them to go to whatever depth they need to be. Buoyancy is measured with Archimedes' Principle. Archimedes' Principle says the buoyant force is equal to the weight of the fluid displaced by an object submerged in the fluid. So essentially it's the weight of the fluid you push out of the way. So when a boat is sitting in the water, the boat is pushing down on the water. It's pushing the water out of the way. It has to push a weight of water out of the way greater than the weight of a boat. If you've ever been in a canoe, you know as more people get in the canoe gets deeper and deeper in the water. What the canoe is doing, or how it's designed, is to push a greater amount of water out of the way as more people are added to it. At a certain point, as people continue to get in the canoe, it can no longer push enough water away, so the weight of the water is greater than the weight of the canoe, and it'll start to sink. This is why boats have a maximum occupancy, because they're designed to push a certain amount of water out of the way. Heavy boats are going to ride lower because they need to push more water out of the way. If they can't get enough water out of the way, they're going to sink. Boats float higher in salt water than they do in fresh water because the salt water is more dense, so the volume of water that they push out of the way weighs more. That's why they're going to ride higher in salt water.